In this next lesson, we discuss how to solve equations where we have variables on both sides of the equation. So before you see the equation 8x plus 3 is equal to 3x plus 38. And we still want to isolate the variable x. So that's step one. The goal is, if you will, the goal is to isolate x. Secondly, in order to do that, what I prefer to do is move variables to one side and what I call constants to the other. And third, I try to keep variable constant or variable coefficient positive. So what I'm going to do is I'm going to look at these two variable terms and see which one's bigger. So 8's bigger than 3. I'm going to move my variable terms to the left and my constant term, which is 3, to the right. Just a preference of mine. So in order to move the variable term, I'm going to take, and I have a positive 3x here, I'm going to add a negative 3x to both sides. When I do that, 3x plus negative 3x goes to 0, and 8x plus negative 3x is 5x plus 3 equals 38. And now we have a multi-step equation or a two-step equation to solve. I add negative 3 to both sides. $5x will then equal 35. 5 happens to go into 35 evenly, so I'll divide both sides by 5. You can multiply by 1/5 if you wanted to. So x is equal to 7. Let's do a quick check. I have 8 times 7 plus 3 equals 3 times 7 plus 38. 8 times 7 is 56 plus 3 is 59. 21 plus 38 is 59, and the problem checks. Now let's take a look at a couple special cases of this concept. You'll notice I have 5x plus 4 is equal to 5x plus 10, and we want to isolate x and bring the variable terms to one side. But when I do this, notice what happens. I add negative 5x to both sides, and you'll notice 5x plus negative 5x goes to 0, and over here 5x plus negative 5x goes to 0. So I'm left with this following statement, that 4 equals negative 10. We know this is not true. So what this says is it says there's no solution. In other words, no value of x will make the two sides of the equation equal. Another way to write no solution is like a 0 with a line through it. That works as well. Now let's look at the equation over to the right. I'm going to distribute first both of these. So I have 2x plus 16 is equal to 2x plus 16. Now if you were to get the variables on one side again, and bring this over, I could subtract 2x to both sides, 2x to both sides, and 2x minus 2x is 0, so 16 equals 16. If you ever end up with a true statement, no more variables, then we say our solution is all real numbers, which means I can pick any number, plug it into the x on both sides, and the two sides of the equation will be equal. So those are two special cases that you might have. So let's go through a number of different examples for solving equations with x on both sides. In this problem, I've got denominators. One denominator being a 4, one denominator being a 2. They're also fractions. So I want to clear the fraction, which means I'm going to multiply all the terms by my LCD. And in this case, my LCD is equal to 4. So notice what happens. I multiply a 4 to everything. 4 times 4x is 16x. 4 times 3/4, the 4 is reduced, and I'm left with 3. Well, I'll just write it out. Yeah, let's leave it as 3. 4 over 2 multiplies to 2, and there's an x there, so that's a negative 2x. And 4 times 5 is 20. Now, again, we notice that 16 is the variable term here, and negative 2 is the variable term here, and I want to keep my variable terms positive. So I'm going to bring the 2x over to the left. And to do that, that's a negative 2x. I'll add a positive 2x to both sides. It's a terrible x. When I do that, I get 18x plus 3 is equal to, that's 0, plus 20 is 20. That's adding 3. Since this is positive, I'll subtract 3 to both sides, or I could add a negative 3. It doesn't matter. Just be somewhat consistent. I have 18x equals 17. And now I need to take and get rid of this multiplication of 18x. I can multiply by 1/18th, and I'm only doing 1/18th because it doesn't go into 17 evenly. So I'm going to get some kind of a fraction in the end. So 18 times 1/18th is 1x, and that's equal to 17 over 18, and the problem is done. Let's go through another example. So I have two distributions I have to make here. And you'll notice I have lots of subtractions. When I have subtractions, at least early in algebra, I like to say, well, subtraction is the same as adding the opposite. So I'm going to make all my subtractions adding the opposite of the term next to it. So you'll notice in this case I have a 4 times a 2, which is an 8, and a 4 times a negative 5x, which is negative 20x, plus 8 is equal to 6. Negative 3 times positive 8 is a negative 24, and negative 3 times a negative 6 is a positive 18x. So now you'll notice I have like terms on each side that I'm going to combine. This is negative 20x plus 16 equals 6 plus negative 24 is negative 18 plus 18x. Once again, I want to keep, if at all possible, the coefficients of x positive. So I must bring this negative term to the other side. In order to do that, since this is a negative 20, I'm going to add a positive 20x to both sides. This gives me 16 is equal to negative 18 plus 38x, adding like terms. I want to isolate the x term. First, I'll do that by bringing this addition or subtraction to the other side. So this is a negative 18. I'm going to add positive 18 to that and do it to both sides. Negative 18 and positive 18 gives me 0, so I'm left with 38x. And on this side, I have 34. So now I'll try to isolate x by multiplying by the reciprocal of 38, or 138, to both sides. Could divide by 38. Gives me 34 over 38 is equal to x. I'm never going to leave something in a form that's not reduced. I know 2 goes into both of those. On top, 17 times. On the bottom, 19 times. So my answer is 17/19. So in this next problem, again, we have multiple distributions we have to do, and we also have fractions. So let's see how we're going to handle this. I'm going to distribute through just like I did in the last problem. I also have these subtractions, so I'm going to add the opposite once again every time I see a negative or a subtraction. And then I have 3 plus 2/3 times x is 2/3 x. 2/3 times 1/4 is going to be 2/12, but I can reduce that because 2 and 4 reduce. So that's going to be a negative 1/6 x. And then I have 4. Negative 5 times x over 2 is the same as negative 5 times 1x over 2. So that ends up being negative 5 over 2x. And then I have a negative 5 times a negative 4, which is a positive 20. So in this case, again, I notice I have some like terms, but I've got fractions in the problem now, and I'm not a big fan of those fractions. So I'm going to look across both sides of the equation and see if I can find a common denominator of 3, 6, and 2. Well, that happens to be 6. So now if I multiply all my terms by 6, I should be able to clear all the fractions out. 6 times 3 is 18. 6 times 2 is 12, divided by 3 is 4, x. 6 times 1 is 6 over 6 is 1x. 4 times 6 is 24. 6 times negative 5 is negative 30. But then I divide that by 2, and I have negative 15x. And 6 times 20 is 120. And you'll see all the fractions went away. Now I'll try to combine like terms on each side of the equation. Since there's nothing in front of this x, it's a 1. So I have 5x plus 18 is equal to negative 15x plus 144. So now I'll try to keep my variable term positive, which means I want to bring this negative 15x to the other side. So I'll add 15x to both sides. Which gives me 20x plus 18 is equal to 144. Next, I'll take and isolate the x term by doing the opposite of adding 18 to both sides. So I'll add a negative 18 to both sides, which leaves me with 20x on the left, and 144 plus negative 18 is positive 126. I need to isolate the x once again, so I'll multiply both terms by 1/20. You'll notice x is equal to 126 over 20. I know 2 goes into both of these, 53 times in the top, 10 times on the bottom, and I'll just leave my answer like this. No mixed numbers. Now, this next problem looks relatively basic compared to the last problem we did. However, there is a trick in it. And the trick comes in the first step. We can see there's a distribution here, but this doesn't look like a distribution, and in actuality it is. When you see a minus this term, what that really means, because like I said, I like calling subtractions adding the opposites. So when there's nothing in front of this parentheses, there really is, it's a 1. So I'm going to put a little 1 in front of that guy. And then I'm going to say, let's just take and add the opposite of that. So now we have a multiplication of -1 to that parentheses. So what I have is I have now 7, and -1 times +2x is a -2x. I see another subtraction, so I'm going to add the opposite again. And -1 times -5 is +5. There's a subtraction again, so I'm going to add the opposite. And I have 8, and -3 times -3 times +9x is a -9x, and -3 times a +4 is a -12. Combine like terms on the two sides. This gives me a -2x plus 12, and on this side I have a -9x and a -4. So again, I want to make my variable term positive if at all possible. So this is the bigger negative. If I bring that over to the other side, it's going to outweigh the smaller negative and thus create a positive answer. So I'm going to add +9x to both sides, giving me 7x here, 0 there. That's 7x plus 12 is equal to -4. I'll then take and get rid of this constant term of 12 by bringing it to the other side. So I'm going to add a -12 to both sides. Leaving 7x on the left and -16 on the right. I want to undo the multiplication of 7. So I'll multiply both sides by 1/7. And my answer will end up being -16 over 7. Now for a couple of word problems. Let's read through it first. 5 times the sum of a number and 3 is the same as 3 multiplied by 1 less than twice the number. So again, we're going to have to be careful in how we go ahead and write this. Here's the first part. 5 times the sum of a number and 3 is, there's your equal sign, the same as, there's your equals, 3 multiplied by. So this is 3 times something. So being conscious of this, let's move on. So we take 5 times the sum of a number and 3. So some number, we don't know what it is, let's call it n, and 3, that's adding, is the same as 3 multiplied by 1 less, so that's 1 less, subtracting 1, then twice a number. There's that same number, but 2 times it, because that means twice. So here's our equation. We can take and distribute now. 5 times n is 5n, plus 5 times 3 is 15. 3 times 2n is 6n. and 3 times negative 1 is negative 3. And remember, if you don't see the negative 1 there, you add the opposite. So now I want to keep my n term positive. I'm going to bring this 5n to the other side by adding a negative 5n. Leaving me with 15 on the left. 6 plus negative 5 is a positive 1n plus negative 3. Going to add the opposite to both sides. So I'm going to add 3 to both sides. And I end up with 18 equaling n. And if I wanted to check that, it wouldn't be too difficult. You could just plug it right back in. So let's do that real quick. I had 5 times 18 plus 3. And that was supposed to equal 3 times 2 times 18 minus 1. So on this side I have 5 times 21, or 105. And on this other side I had 3 times, that ends up being 36 minus 1, or 3 times 35, which happens to be 105. So that checks out. Let's look at one more. It says tripling the greater of 2 consecutive integers. Well, before I even start, I'm going to list my 2 consecutive even integers. The first, we always say, is our unknown n. And then the second sets its consecutive even. Consecutive evens are like 2, 4, 6, 8, 10. Those are all 2 apart from each other. So that's n plus 2. And then going back to the problem, it says tripling the greater of 2 consecutive even integers. Well, the greater, since this is adding 2 to it, must be more than just n. So I'm going to triple that. 3 times that greater term gives the same result, which means is equal to subtracting 10 from the smaller integer. Well, this is the smaller if this is the larger. So that's n. I have my equation. I can now distribute and say I have 3n plus 6 is equal to n minus 10. I'm going to get all the variables to one side, so I'm going to add a negative n to both sides of the equation, leaving me with 2n plus 6 is equal to negative 10. Add a negative 6 to both sides, get 2n equals negative 16. Since 2 goes into negative 16, I'll just divide both sides by 2, leaving me with n equaling a negative 8. Now, it asked me to find the 2 integers. I've only found one. So if n equals negative 8, then n plus 2 equals negative 8 plus 2, or negative 6. So here's one integer, here's the other integer. And then to check it, it said tripling the greater of 2. Well, negative 6 is actually bigger than negative 8. So if I triple that, 3 times that negative 6 gives the same result as subtracting 10 from the first, and that was negative 8. Notice negative 18 is equal to negative 18. So I have a check. Here's a geometrical problem. we want to take and find h so that the figures have the same area. Both of these are triangles. You know the area of a triangle is 1/2 the base times the height. So in this case, I have 1/2, let's call the base 6, times the height is equal to 1/2 the base, call that 10, times the height. And in this case, the height is equal to h minus 2. So we do our multiplication. This is 1/2 times 6, which is 3, times h is equal to 1/2 times 10, which is 5, times h minus 2. Distribute the 5 through, get 5h. Notice subtraction, so I'm going to add the opposite. And I have 5 times -2 is -10. And that's equal to 3h. Now, in this case, if I want to keep my h terms positive, I have to bring the 3h over. Now, let's just do something a little bit different this time, because I don't want to have nothing on one side of the equation. I want to keep it constant. So I'm going to take and add -5h to both sides, or break my rule a little bit. And it's okay to do as long as you keep track of your positives and negatives. So now what I have is I have -2h is equal to -10. And you'll notice the 2 goes into 10 evenly, so -2 must go into -10 evenly. So right here I have a multiplication of -2 to h. In order to undo that, I divide by -2. If I do it to one side, I have to do it to the other. So negative over negative is a positive h, and -10 divided by -2 is 5. So my height value is equivalent to 5. That's all there is for today. Fill out your summary, find the answers to these problems, put them on the forum, and we'll see you tomorrow.